Hello, I am Rashid Ansiri and I am a doctor engineer and a technologist in mechanical engineering, and I will try in this video to technologically introduce the welding polarity in SMAW process, of course as simply and as clearly as possible. So first of all, it should be remembered that, as I said in the previous video, that SMAW means Shielded Metal Arc Welding, and it is the most basic and the most used type of welding in industrial applications. And it's to note here that when we practice the SMAW process, we can use a direct current DC or an alternating current AC. And when we use the direct current, we talk about constant welding polarity. And when we use the alternating current, we talk about variable welding polarity. And the questions here are: what is welding polarity, and how the type of the current, direct or alternating, will influence the type of welding polarity, constant or variable. Now I will talk about the welding polarity when we use the direct current, and it is to note here that depending on whether the electrode is connected to the negative or the positive terminal of the arc welding power source, we have straight polarity or reverse polarity. So the straight polarity is called also DCEN, which is an abbreviation that means direct current electrode negative, which means obviously the electrode is connected to the negative terminal. The straight polarity is also known as DC minus, and as you can see in the figure, in the straight polarity, the electrode is connected to the negative terminal while the workpiece is connected to the positive terminal, and the red arrows indicate the direction of the electrons flow. And below you can see a cross section of a weld bead on a workpiece, the weld bead in red and the workpiece in blue, and you can get an idea about the aspect of the weld bead obtained when we use the straight polarity. Now for the reverse polarity, it is called also DCEP, which is an abbreviation that means direct current electrode positive, which means obviously that the electrode is connected to the positive terminal of the arc welding power source, and the reverse polarity is known also as DC plus. And as you can see in this figure, the electrode is connected to the positive terminal of the welding machine, called also arc welding power source, and the workpiece is connected to the negative terminal, and the red arrows indicate the electrons flow. And below there is a cross section of a weld bead on a workpiece, the weld bead in red and the workpiece in blue, and you can get an idea about the aspect of the weld bead obtained when we use a reverse polarity, of course in SMAW process. Now I will talk about the influence of the welding polarity on the weld bead aspect. And as you can see in this figure, where the weld bead is the hatchet area and the white area is the workpiece, that the weld bead aspect is mainly characterized by the width of the weld bead, noted W, the height of reinforcement, noted R. This height of reinforcement is the distance between the surface of the workpiece and the top of the weld bead, and there is also the penetration P, which is the distance from the surface of the workpiece to the bottom of the weld bead. Now I will try to summarize the influence of straight polarity and reverse polarity on welding. And first of all, it is to indicate that the heat generated by the electric arc, in other terms the welding heat that we will use to produce weld beads, will be shared by the workpiece and the electrode. And when we use the straight polarity, 2/3 of this welding heat will be near the workpiece, and the remaining 1/3 of this welding heat will be near the electrode tip. And when we use the reverse polarity, only 1/3 of this welding heat will be near the workpiece, and 2/3 of this welding heat will be near the electrode tip. This will influence the weld bead penetration, which is associated to the workpiece melting rate. In fact, when we use the straight polarity, since 2/3 of this welding heat is near the workpiece melting rate will be high, and consequently the weld bead penetration will increase. But when we use the reverse polarity, since only 1/3 of this welding heat will be near the workpiece melting rate will be low, and consequently the weld bead penetration will decrease. And also, when we use straight polarity, since only 1/3 of the welding heat will be near the electrode tip, the electrode filler deposition rate will be low, and the weld bead reinforcement and the weld bead width will consequently decrease. But when we use the reverse polarity, since the 2/3 of the welding heat is near the electrode tip, the electrode filler deposition rate will be high, and consequently the weld bead reinforcement and the weld bead width will increase. And you can see below a cross section of a weld bead on a workpiece, the weld bead of course in red and the workpiece in blue. And you can see that when we use the straight polarity, the penetration of the weld bead is more pronounced than the height of reinforcement and the width. But when we use the reverse polarity, the height of reinforcement and the width are more pronounced than the penetration. Now I will talk about the welding polarity when we use an alternating current. And as you can see in this figure to the right, the flow of electrons is in both directions, so the connection of the electrode to the welding machine will be alternated between negative terminal and positive terminal. Thus, the welding polarity will be alternated, and as you can see in the figure to the left, this welding polarity will change 120 times per second. This supposes that the frequency of the electric grid is around 60 Hz. But if we suppose that the frequency is around 50 Hz, the welding polarity will change only 100 times per second. The table below indicates the aspect of weld bead when we use straight polarity DCEN to the left and reverse polarity DCEP to the right, and in the middle there is the aspect of weld bead when we use an alternating current, in other terms when the welding polarity is alternated. And you can notice that there is a balance between the weld bead penetration on the one hand and the weld bead reinforcement on the other hand. This is expected since there is an even welding heat distribution between the workpiece and the electrode when the current is alternated. So this is the end of this educational video. Thank you very much for your attention.